All right, let's dive right in. Right now, Windows 11 version 26H2 has officially hit the release preview channel as build 26300.9278. And look, if you're an IT admin, a systems engineer, or anyone managing endpoints, this is absolutely not just some routine insider chatter that you can brush off. Why? Because if you fail to control what Microsoft calls the seeker experience, while you could be looking at rogue, completely unmanaged 26H2 updates deploying across your entire fleet today, completely bypassing your change control. So in this explainer, we're going to break down a really critical guide from Endpoint Weekly on exactly how to test and prepare your Intune environment for this update way before general availability. Let's get to it. To get you fully prepared, here's our roadmap for today. We're covering the release preview shift, shared servicing, and EKBs, how to verify your current fleet, building that Intune pilot, setting up rollback safety nets, and finally, we'll wrap up with a production readiness checklist. Kicking things off with Part 1, the release preview shift. So in previous milestones, Microsoft's usually aimed pre-release code at, enthusiasts running throwaway hardware. But release preview? It's a totally different beast. It is explicitly designed for commercial validation in environments just like yours. And the shift in deployment scale here is honestly pretty wild. Think about it. In the past, rolling out a feature update meant pushing a massive 6.5 gigabyte payload, which, let's be real, absolutely crushed your network. But now, if your fleet is already on recent builds, 26H2 deploys as a tiny 174 kilobyte enablement package. It's essentially instantaneous. One standard restart and boom, they're upgraded.
Moving right along to Part 2, shared servicing and EKBs.
To really understand why this update is just so incredibly small, we have to talk about enablement packages, or EKBs, because here is the secret sauce. 24H2, 25H2, and 26H2, they actually all share the exact same underlying codebase. Yeah, Microsoft has actually been sort of secretly delivering the 26H2 code to your devices for months now, just hidden away inside your standard cumulative updates. That code is already on the drive, just sitting there, completely dormant. So the EKB's only real job is to essentially act as a switch. It just flips a few registry-backed feature flags to on and bumps up the build number. That's the whole shebang. Now, your actual upgrade path is going to depend entirely on what your devices are running today. It's not a one-size-fits-all deal. If a device is already on 24H2 or 25H2, lucky you. It gets that lightning-fast 174 kilobyte EKB. But what about those devices lingering on 23H2 or older? Well, they're going to require that full 6.5 gigabyte media. 26H1, that needs a full upgrade too. And if you've got machines still on Windows 10, you are looking at a total OS replacement. Knowing exactly where your starting line is for every single endpoint is absolutely essential so you can actually budget your network bandwidth effectively. And this right here illustrates a major trap that so many admins fall into. Look, just because the payload is only 174 kilobytes does not mean you get to skip your pilot phase. Sure, the blast radius might be narrow, but those newly flipped feature flags, they can absolutely break your lockdown settings catalog profiles. They can conflict with your Defender attack surface reduction rules, or they could literally just break any kiosk or custom shell replacements you might be running. Bottom line, you still have to test, period. Which brings us to Part 3, verifying your current fleet. So before you even think about pushing a single pilot policy, we have to verify your current fleet's posture. You simply cannot plan an upgrade path if you don't confidently know where your devices are starting from. You're going to want to run this exact PowerShell command across your endpoints. By using get-computerinfo, we're pulling the Windows product name, the OS version, and the OS build number. Honestly, this is the absolute fastest way to read the true feature update posture of a local machine before you even try deciding which upgrade ring it belongs in.
Now, here is a classic Microsoft quirk that trips up a lot of engineers, so pay attention. Windows product name is, frankly, notoriously unreliable. Your machine might explicitly claim it's running Windows 10 Enterprise, while the OS build number reveals it's actually running 26200, which is a Windows 11 build. Crazy, right? So never, ever trust the product name string alone. Strict reliance on the OS build number is literally the only way to know the truth. And hey, if you run this and see a device on build 26300 and you know for a fact you didn't put it there, well, that means the automated seeker experience has already reached your fleet.
All right, on to Part 4, building the Intune pilot. Okay, once you've audited your fleet, it is time to safely isolate a group of devices to test out this release preview build. Now, when you're in the Intune Admin Center, whatever you do, do not use the newer feature updates policy just yet, simply because 26H2 isn't generally available. Instead, what you'll do is go to Update Rings and create a brand new profile specifically for this pilot. Set your feature update deferral period to straight 0. Then you want to explicitly enable pre-release builds and select the Windows Insider Release Preview channel. Finally, assign this to a carefully chosen pilot ring. We're talking maybe 5 to 20 devices that actually accurately represent your real hardware and software stacks. And please, do not touch your existing broad rings. Those are your control group. Leave them alone. Now, after you assign that policy, don't just blindly trust the Intune console when it happily says success, because a conflicting local GPO could still be blocking it in the background. Instead, run this specific registry query locally on a pilot device to check the branch readiness level. Just query that Windows Update key. If the policy actually applied correctly, you should expect to see a value of 8, which corresponds to the release preview channel. Doing this gives you actual command line confidence that the device is truly ready to pull down that EKB. Let's look at Part 5, Rollback and Safety Nets. Because, let's face it, if your pilot reveals some massive regressions, say, I don't know, a critical business app just totally crashes on 26H2, you absolutely need a reliable safety net. 30. That is the magic number. That's exactly how many days you need your rollback window to be. See, by default, Windows only gives you this tiny 10-day window to revert and update. And for a proper enterprise pilot, that simply isn't long enough to capture things like end-of-month accounting workflows. We absolutely need to extend it. So to do that, you must run this exact dism command from an elevated prompt. dism/online/set os uninstall window/value 30. But hey, the absolutely critical detail here is timing. You have to run this command immediately after the upgrade completes. If you wait around, normal disk space pressure or maybe some automated cleanup script might just wipe out that windows.old directory. And if those rollback files are gone, this command will instantly fail with an element not found error. And at that point, your only way back is a full bare metal reinstall, which nobody wants. Finally, Part 6, the Production Readiness Checklist. Now that your safety nets are firmly in place, we have to look at your exit criteria. The most crucial point here is that you cannot move forward to production based on a green enough signal, okay? Every single item must be definitively green. You have to prove the pilot devices took the update specifically via your policy, meaning you verified the branch readiness level is 8. You need to verify event 19 actually fired in the event viewer for KB5120998. And finally, make sure you log the exact upgrade date and confirm that your 30-day rollback window is actively applied across the board. Which honestly leaves us with a pretty critical question to end on today. Think about it. If you were to audit your endpoints right this second, are your pilot devices truly isolated and strictly under your control? Or is that automated seeker experience already running your rollout behind your back? Microsoft has absolutely given us the tools to validate 26H2 cleanly and safely before general availability, but it requires you to take deliberate action right now. So take these commands, go check your environment, and build that Intune pilot ring the right way. If you found this explainer valuable and it helped you out, please make sure to like and subscribe for more deep dives into Microsoft Endpoint Management. And definitely drop any questions you have about 26H2 in the comments down below. We'd love to chat about it. Thanks for hanging out, and we'll catch you in the next one.